Okay, let's try and actually get the stream at the beginning. So this is chapter 5 of Dennis Wixom and Tegarden System Analysis and Design with UML 5th edition, talking through structural modelling. Let me get the right page. Right, so the objectives here are to understand the rules and guidelines for making CRC cards, class diagrams and object diagrams. We haven't talked about CRC cards, we have talked about class diagrams. So we want to understand the processes of creating these three things. We want to be able to create them, and what's the relationship among the structural models, and how do we work between structural and functional models. So functional models represent system behavior. Structural models represent the system objects and how they interact with each other, their relationships, right? People, places, and things. So we do it using an iterative process. We draw, first of all, in a conceptual business-centric way. Then we refine it into a more technology-centric way. And as we iterate, we add more and more detail so that we move from the analysis of the requirements through to the design of the software. And there's not just one big leap from analysis and design to design. It's an iterative polishing process. So part of what we want to do with a structural model is to create a vocabulary for the analysts, you, and the users of the software so that we can communicate effectively. Right? So we've got to go from the problem domain into the solution domain and build a structural model of the things in the problem, of representations of things in the problem domain. So here's a class diagram. The top is the name of the class. Sometimes you have a stereotype in the top saying that it's a particular sort of class. I've used interface or boundary and controller and entity stereotypes for some of the classes I've talked about. Then we have the attributes. They're the properties that describe the state of the class. And then they're the operations, the functions, the methods that are the actions of the class. Right? The relationships, and there are three here, show the relationships between classes. Right? Generalization is inheritance. Aggregation represents the parts of a class that may be represented by other classes, and association is a weaker form of aggregation that says that one class must know about the other class. We've talked about how to figure out what the objects are. A way of doing it is looking at all the nouns in the text we have about the system. It also helps to brainstorm, right? Both to find classes, but also to find the attributes, the operations, and the relationships when you do that. Common things that you would have in an object are physical things, incidents, roles, or interactions. There are patterns that you can use that are solutions to commonly known problems, and we might talk about some patterns later on once we get into a little bit further along with the design. We've talked about class diagrams before in class. What I haven't talked about are CRC cards, right? These are cards that are physical, usually index cards, used to document the responsibilities and the collaborations of a class, right? What they know, what they do, who they work with, and whether there's any contracts in that working with other classes. Here's an example. You've got the class name, the ID, the type, a brief description, how many use cases this particular class is used in, what the responsibilities of this class are, and who or what the class collaborates with. On the back side, you've got the more details, you've got attributes and any relationships between this class and other classes or actors. CRC cards, they're usually physical because it helps to role play through a use case or an activity diagram how these objects flow through the system, right? You identify an important use case, you assign roles to the members of the team based on actors and objects. The team members then perform each step in the scenario, and you discover and fix problems when you do it. Okay, so here's more detail on class diagrams. It's a static model that shows classes and their relationships to one another. Right, the elements of the classes, the relationships between them. On a class, you've got properties, right? The last name, first name, address for a person. They may be derived, and you can have visibility. And there's the three types of visibility: public, private, and protected. Right? Public, anybody can see it. Private, only the class can see it. Or rather, objects of the class can see it. And protected, it's only visible to an instance of the class they were defined in and its descendants. Right? Private is not visible to descendants. You don't usually add common operations like the constructor and destructor. That's assumed because we're doing object oriented, but there might be other things that you may need, like queries and updates. So the relationships, and you may have classes related to themselves, and you should also have a multiplicity. Right, so here's an example of multiplicity. Each department has only one boss, and each boss is only boss of one department. Is an employee, and that employee has 0 to many children, and a boss has 1 to many employees, but an employee has, within this organization, has only one boss. Right? Association classes are usually derived classes that connect to other classes. Right? So, for example, students are related to courses, and a grade class connects the student with the course by adding the grade field. As we've said before, generalization denotes inheritance. Aggregation is a logical part of relationship, and composition is a physical part of relationship. So aggregation, it's just there because that's the way we do the software. But composition, there's a physical reason, a real world reason for one object only living at the same time as the other object. And here's an example class diagram. You can see all of the, there's inheritance, there's multiplicities. You can see here, oops, let's go back to that. You can see down here that this is a relationship between a symptom and an illness, and it's called a treatment. This is an example of that class associating two other classes. Here's an example of a class needing to refer to itself, right? And I think that's about all I wanted to put up on here. So as you can see, fully populated class diagrams with real systems can be hard to understand. So it helps if you simplify the diagrams by sometimes constraining or containing lots of classes into a package and only showing the package, for example, or only showing a subset of classes at any one time. My usual guidance is 5 to 9 classes, just like my guidance with use cases, 5 to 9 use cases. Let's just go back here. Here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We've got 22 classes on this. That's a little too many. And I would probably, the first thing I'd probably take off this diagram to simplify it are the inheritance relationships, and have a separate diagram for the employee, or for the participant, maybe employee, the participant inheritance diagram, and a separate diagram for the item inheritance hierarchy. Okay, object diagrams. Objects are instantiated classes, right? So now we've got we've created the class and we've filled in some of its attributes. Right, and here's an example of an object diagram. The main, so the top, well, the top one is the class diagram, and the bottom 4 boxes show the object diagram with all of the fields filled in appropriately. Okay, what do we need to do to create structural models? Create CRC cards, review the cards for missing stuff, role play the cards, create a class diagram, review the class diagram, incorporate any patterns that we're aware of, and then review and validate it against the use case diagrams and the activity diagrams. Right? Walkthroughs are useful. So for each CRC card, it's associated with one class. The responsibilities are included as operations on the class diagram. Got to make sure that's true. Collaborators on the front of the card imply a relationship on the back, and attributes on the back are listed as attributes in the class diagram. Attributes on the back each have a data type, right? We need to know whether it's an int or a float or some other class. Relationships on the back must be on the class diagram, whether it's aggregation, association. We also must have the multiplicities, and association classes are used only to include attributes that describe a relationship. That was the relationship between the symptom and the where was it? The symptom and the illness, right? This treatment is an association class, as indicated by that dotted line. Okay, we've talked about structural models, CRC cards, class diagrams, object diagrams, and how we create them. That's it for